Let us start. Online team, can you hear me? Can somebody please respond? Online team, is my voice is clear? Okay, let us start. I'm sure decision tree we done. Random forest. What is the next algorithm, sir? Random forest. We done this. So the next topic is, let us make it the careful cross validation. Yeah, I still remember confusion matrix and bias variance trade-off we can cover. All right, come on, let us start. So I hope yesterday already covered. Random forest is a supervised learning technique. It can be used for both what exactly, sir? Classification and regression. But remember one thing, in this world, there are more classification problems. There are more what exactly? Classification problems. Then you can see more classification algorithms. Random forest is a concept of ensemble learning. Ensemble learning means what exactly we are doing, Let us take a single model will give the one prediction. Instead of that, let us just try to group the model. Let us just try to create a 10 models or 20 models or 40 models. Then let us just try to get the average result. Actually, that is really very good. That is called as a ensemble learning technique. What technique, sir? Ensemble learning technique. So this is the process of combining group of models, group of classifiers to solve a complex problem and improve the performance of model. Actually, okay, I'm sure yesterday we done these all. Am I right or not, sir? Talk with me. No, this you need to walk through. Use case, okay. This theory I didn't cover. This one I didn't cover. Okay. So why use random forest? It takes less training time compared to the algorithms actually. It takes less training time compared to what exactly? All compared to other algorithms. Can somebody tell me? Yesterday we solved one problem. What is that problem statement? Any idea? Decision tree. What is the problem statement? Did you remember? Like we have taken company. Next one is job. Next one is a kind of some qualification degree, and finally we are deciding salary. Finally we are deciding what exactly? Salary. Sir, what you need to do, the same problem you need to try with logistic regression. The same problem you need to try with what exactly? logistic regression and check the result actually. I mean to say that a same, I mean, the same problem can other algorithm also can solve. Other algorithm also can solve actually. Then you need to check the score. Which algorithm is giving the good score, that algorithm we need to move on actually. Are you getting what I'm saying? And maybe that I'm going to cover, don't worry. Not immediately. During k-fold cross validation, you will understand. It takes less training time compared to the other algorithms. It is doing prediction, prediction output with high accuracy. Even for the large data sets, it's run efficiently. There are few algorithms. If the data set is a very bigger, actually, sorry for saying, the performance is very slow. But when you're talking about the RF, it's called as a random forest actually. Even though the data set is very bigger, it works very well. It works very well. It can also maintain accuracy when a large proportion of data is what exactly missing. This is seriously interesting. What you need to understand, come on. First one is what exactly? Data. Next one is a data frame. Next one is what exactly? Feature. Assuming that there are missing values, what we need to do? We need to apply feature engineering. Then after that, what is the next one? Array. Then after that, what is the next one? ML. Next one is what exactly? Gradient descent algorithm. And next one is what exactly? Cost function. Sir, assuming that when you're talking about the random forest actually, if data is missing, if the data having missing values, still you can proceed. Random forest works very efficiently actually, right? I will show you that one as well. Now read this one. It can also maintain accuracy when the large proportion of data is missing as well. And how does random forest algorithm work? There are two steps actually. First, it creates a random forest with n decision tree. And second, it can make predictions for each tree actually. Now I would like to tell. Simple, sir. The first one is a decision tree. First one is what exactly? Decision tree. It is a single algorithm. What algorithm? Single algorithm. Let me take random forest. Let me take what exactly? Random forest actually. When I say random forest, this one also algorithm. This one also what exactly? Algorithm. But let me tell you, this algorithm having group of decision trees. Having what exactly? Group of decision trees. Decision tree. Instead of depending upon this single algorithm, here what exactly we are doing, we are depending upon the group of decision trees. Depending upon what exactly? Can somebody tell me this technique is called as a ensemble technique? What technique? Ensemble technique. Now let me show you the example. Again, one more public data set, sir. So this theory you will understand. Hold on. Once you understand the algorithm, you will understand. So let me just try to help you. This is a very basic example. Uh, let me tell you. Can somebody talk with me? Online team, are you fine, sir? Is my voice is clear? I hope you are able to hear. Okay. Is anyone selected for H1B? Is anyone? Okay. There are two of old batch students got selected, sir. H1B. First of all, do you know H1B? Oh, no worries. Then let me not talk actually. Yeah. Can somebody tell me, till now we have seen the public data sets, right, sir? Till now we have seen what exactly? The public data set. The first one is a, come again, Titanic data set. Titanic data set actually, I hope you know. Now today, let me show you Iris data set. What data set? Iris flowers data set. Iris what exactly, sir? Flowers data set actually. And let me explain about this one. And so that you will get a very clear picture. So first of all, this is the flowers data set. This is what data set actually? Flower data set. The first one. There are four types of flowers. How many types of flowers? Four types of flowers. When you're talking about the flower, every flower having, sepal length. What is the first one, sir? Sepal length. Next one is sepal width. Sepal width. Next one is any idea? Petal length. Next one is what exactly, sir? Petal width. First of all, remember these are all features actually. I'm repeating one more time. Sorry. Good. Come on, one more time. When you're talking about any flower, I will show you the diagram. Every flower having, there are mainly four features. How many features? Four features. The first one is a sepal length. What is the first one, sir? Sepal length. Sepal length. Second one is a sepal width. Third one is petal length. Fourth one is petal width actually. Good. Even we are going to working with the data set. The data set name is called as a iris flowers. Yes, exactly. Every flower having sepal length, sepal width. Petal length, what exactly? Petal width. Based on this measurement only, deciding the flower. We will decide. We will decide the flower based on what exactly, sir? Measurement. Based on what exactly? Measurement only. I hope you understand. Are you getting what I'm saying? Good. Let me tell you, there are mainly four types of flowers. How many types of flower? Four types of flowers. Let me show you. What is our problem statement? Just try to ignore this theory. Yeah, when you're taking about the flower, I would like to say this is the sepal. Sepal having the length and sepal having what exactly? Width. This is called as a petal. Petal having the length and petal having what exactly? Width actually. Length and width. Length and width. Every flower. Now, please observe this one. Sir, sorry, sir. This is not four types, three types. Three types of flowers. Though this is the public data set, right? Can somebody talk with me? The first two types of data set is called as the first two type of flower is called as a versicolor. What is the first one? Versicolor. Second one is a setosa. Setosa or setdosa, sir? Setosa. And last one is a virginica. I mean to say that there are three types of flowers in a forest. Assuming that there is a forest actually, there are mainly three types of flower. The first one is a versicolor, second one is setosa, next one is what exactly? Virgica. Did you notice one thing? Flower to flower, the measurements are quite different. Flower to flower, what is quite different actually? Seems to be same color, seems to be what exactly? You may notice, recently I have seen one advertisement actually, Iris shampoo, something like that. Even I'm not sure. Either you have seen or not, but I have seen. Good. Now, every flower having sepal and petal. Every flower having what exactly? Sepal and petal. Sepal having two measurements. Talk with me. What is the first one? Sepal length, sepal width. Petal having two measurements. Talk with me. Petal length, petal width. Yeah, good. Now, yeah, assuming that the first two data set is representing with the zero, nothing but a setosa. Second one is the versicolor. Versicolor means this one actually. Virginia coming in what exactly? No, the last one. Hold on. So this is the public data set, and there is a one function. That function name is called as a load underscore iris. What is that function name? Same thing like that we have called one function recently. What is that function name? Load underscore digits actually. Good. Iris equals to load underscore iris. Then you can cross verify. Same thing like that. Data we are having feature name, file name, frame, target names actually. Can we work on this one? Okay. Come on, let's work on this one. Close this. Very quickly, let me write actually. Print. What is the purpose, sir? Random forest. Now the step number one is step number one. Tell me, importing libraries. Go libraries. And step number two, loading the data set. What is the step number two? Loading the data set. And we are just trying to printing the data set. Step number two, loading the data set. So your internet connection is unstable. Online team, is my voice is clear? I'm having some network fluctuations actually. Yeah. Let's continue, please. Let me run this example. Do you think you will get a full not found error? No. Why? Tell me. Because it is a public data set. I mean to say that the data set is already available inside in SQL. The data set is already they dump actually. They already stored inside in sklearn. Sklearn is a package actually. There is a function name is called as a load underscore CSV. Function calling we are assigning into variable. Good. Keep in mind that function calling we are assigning into what exactly? Variable. Means backend it is having return statement. Just try to see. These are all we are getting. And we'll see. Yeah. Now please observe the next one. I just wanted to see the feature names. I just wanted to see what exactly feature name. Then can I ask a question? What is this one? You have to talk with me. What is this one? Attribute. Good. Let me just try to print the attribute. I just wanted to see only the attributes, Daniel. So simple, sir. Name of the variable. I mean to say that whenever you are calling this function, it is returning one variable or object actually. Object name dot feature name you can call. Can somebody tell me what is output? Nice. Run this example. Just try to see. Yeah. Now tell me, sir. First one is a sepal length. What is the measurement actually? Centimeter. Next one, sepal width. Next one, petal length. Next one, petal width actually. The order is the same. I'm going to showing the data set. The order is the same actually. Now take the output, please. Let's continue. Now target names I wanted to see. At the same time, like a previously, how you are printing feature name. Previously, how you are printing what exactly? Feature name. Same thing like that. Can I print the target names? Actually, you can print iris dot target underscore what exactly? Names. Setosa, versicolor, virginica. These are all three types actually. Let me just try to print this. Let me ask you one simple question. Are you getting what what we are discussing? What is algorithm name? Random forest. Random forest. By using random forest, what exactly we are doing? Hold on. First of all, let me explain. Random forest algorithm, boss. Okay. For this random forest algorithm, we are giving the data. The data set is called as a iris data set. What data set actually? When I say iris data set, it is having flowers data set. What data set, sir? Flowers data set actually. There are exactly three types of flowers would you have. How many types of flowers? Three types of flowers. Three types of flowers. Now every flower having four properties, man. How many properties actually? Four properties. The first one is a sepal length. The next one is sepal width. You have to remember this one. Next one is petal length. Yeah. Next one is what exactly, sir? Petal width actually. Petal what exactly? Width. Okay. Then what we need to do, Daniel? Simple. We are going to create a model. We are going to create what exactly? Model. Then we are going to train with iris dataset. We are going to train with what exactly? Iris dataset actually. Iris dataset. Then after we train, then what is the prediction? The prediction will be, let me provide four properties, something like a 4.2, that is a one value, 1.3, that is another value, 4 point again 3, another value. Can somebody talk with me? 2.3. Can somebody talk with me? What are all these values actually? First one is what exactly? Everyone, one more time, last time. I hope you understand. The first one is a sepal length we are providing. Second one, what we are providing? Sepal width providing. Third one is a petal length. Last one is a, then algorithm will do the prediction. Algorithm will tell, I mean to say that will tell what type of flower it is. What type of flower it is actually. Flower it is. That's a problem statement. Hope you understand. Are you getting? Good. Now get ready. Yeah, I hope iris dot target underscore name. Did you run this example? Did I copy paste it here? No. Let me just try to do that one. Move on to the next one. Then now please observe here. Iris dot data we are calling. What we are calling? Data we are calling. Can somebody tell me what is this one? Any idea? Array. What is this one? Array. Good. Let me just try to call this. Now you tell me what is this data? First of all, array. First of all, what exactly? Array actually. You tell me. 5.1 means what exactly? Nice. 3.5, 1.4, 0.2. Very good. Now what exactly we are doing, We are calling iris dot data. We are calling what exactly? Iris dot data. Very good. Sir, whenever you are calling iris dot data, first of all, it is returning array. It is what exactly, sir? Returning array. Returning what exactly? Array. Array having total 150 rows. Total how many rows? Tell me one more time. How many? 150 rows actually. Tell me. First of all, how many target names would you have? Go back. Oh, did I deleted that? 1 minute. Control Y. Let me just try to print this one. Take this one. Sir, you talk with me. How many rows actually? 150. Then 1 to 50. Next one is 51 to 100. Next one is 1012. What exactly? 150. This is the fixed ratio. This is what exactly, sir? Fixed ratio. The first one is setosa. First one is what exactly? 1 to 50 belongs to setosa features. Next one, versicolor. Next one is what exactly? Versicolor. Next one is what exactly? No, Virginica. Next one is what exactly? Virginica. I'm repeating one more time. There are total 150 rows. There are total how many actually? 150 rows actually. This is the total array. I mean to say that it is divided into 3 parts actually. It is divided into how many parts? Part number 1. Next one is part number 2. Here 1 to 50 would have first 50. Next one is second 50. Next one is what exactly, sir? Third 50 here would you have. Third 50 here would you have. This total 50 features are belongs to what is the first type of flower? Setosa. Now just try to observe this one. Setosa type of features actually. Second one is what exactly? Yeah, same thing like that. And the next one is good. Then let's move on. Now control Y. Total how many rows? 150. 150 rows actually. Now take this example. Let me just try to paste in notepad. I hope any issues with online team. Is target underscore name is an attribute actually? Srikanth? Yes, sir. It should be an attribute. It is an attribute actually. Okay. Srikanth, it is an attribute. Can somebody tell me how we can say this is an attribute? This one also attribute. Control Y, Control Z. This one also attribute. How you can say this one is an attribute? Because we are calling by using an object. That too there is no parenthesis. Simple. We are calling by using object. That too what exactly? No parent. You need to recognize like this. But nowhere else it will written like this is attribute actually. Nowhere else. With coding skill you need to recognize actually. With coding skill. Okay. Come on, let's move on. Yeah, we are checking the length. We are checking what exactly? Length of iris dataset. Now just try to say length of. Length we can cross verify. Then what is the total length, sir? How much you are going to get? 150. Cross verify. You will get 150. Yep. Move on to the next one. Still, we didn't enter into the algorithm. This is something like EDA. We are just doing EDA. Next one. This is seriously interesting. Previously, we have an array. Previously we have what exactly? Array. With that array, can I create a data frame? We can create. With array, can I create a data frame? We can create, sir. Yeah. Iris equals to, yeah, import pandas as a PD. From sklearn dot datasets import load underscore iris. And the load underscore iris function we are calling. Whenever you are calling this function, backend it is having the return statement actually. That's what we are assigning this one. Now PD dot, let me ask a simple question. What is this? Class actually. What is this one? Class. How can you say? Capital letter. D is what exactly? Capital. Sir, fundamentals. Fundamentals. You should not forget actually. Iris dot data. Here we are providing the data. At the same time, columns equals to iris dot feature name we are providing. If you wanted to create a data frame by using creating an object means what all things we need to provide, here data we need to provide, here name, column names we need to provide. This example where we covered, any idea? In data frame, the two data frame introduction. What is the topic name? Data frame introduction. Let me run this one very quickly. You may ask a question, why we are creating data frame? Simple. Why we are creating data frame, let us apply some pre-processing. We'll see what processing we are going to apply. Hold on. This one should be, this is good practice. PD is not defined. PD is what exactly? Not defined. Now let us try to understand. Did you mean ID? Did you mean what exactly? ID. Python is suggesting you, boss, are you trying to calling ID function? What function? ID is a function in Python. By using that, we can check the address of any, variable actually. But I don't want ID. Import pandas as PD. Yeah, we have created a data frame successfully. Very good. The data frame is created, sir. The data frame is created actually. Tell me, 150 rows. Next one is a 4 columns. Now I'm repeating again. Header is not countable for the rows. Header is what exactly? Not countable for the rows. Index is not countable for the columns. Index is what exactly? Not countable for the columns. If index is countable, 1, 2, 3, 4, 5. But it is showing how much actually? 4 only. Keep in mind that whenever you are doing the counting the column names actually, index is not countable. Rule number 1. Rule number 2. Whenever you are counting the rows actually, header is not countable. Column names are not countable. Are you fine? Okay, good. One day, one guy explained demo, right? Why that person is not coming? What happened? Come again? He went to NATO. Okay. At least attending online. What is his name? Is he attending online? I mean online. Good, sir. ఏమంటారంటే ఐఎమ్ సారీ లెట్ మీ టెల్ యూ ఇన్ తెలుగు ఐ నో వన్ వర్డ్ యాక్చువల్లీ వాట్ వి కాల్ మనీదా బెంగేది అంటారు కదా జనరల్లీ జస్ట్ ఐఎమ్ కిడింగ్ బట్ లెట్ మీ టెల్ హీస్ హ్యావింగ్ గుడ్ సబ్జెక్ట్ డిడ్ యూ నోటీస్ హిస్ డెలివరీ awesome. Still, I can remember actually. That's what. Very good, sir. Thank you. I thought, uh, are you pursuing or what exactly currently? Anyway, let's move on, please. Fine, we have created a data frame. We have created what exactly? Data frame. The next one is adding target column to what exactly? Can I add a target column to the data frame? We can add, sir. Sepal length, sepal width, petal width, target column also we are adding. How to add a column? Df of target equals to iris dot what exactly? Target. You can add like this. Observe this one, please. Yep. Sepal length, sepal width, petal length, petal width. The next one is what exactly? Target. Now, please understand. There is a flower, that flower having sepal length measurement is what exactly? 5.1 centimeter. Sepal width is a 3.5. Petal length is 1.4. Petal width is 0.2. What is the target? 0. 0 means which type of flower? 0 means what exactly, sir? Setosa. Setosa. Right. I would like to say this is equals to backend. They have given the coding actually. They have decoded. Ordinal encoding actually. This one is what exactly, sir? 2 actually. 2 or 3? 2. Keep in mind that. Now I have a question for you. Total zeros, how many? Any idea? Very good. Ones, 50. Twos actually, 50. How can we say? Because total how much, sir? Why everyone is not talking? Total zeros how many? 50. Ones how many? If you wanted to get a total zeros, can we get it out actually? How to get it out? Yeah, by using LOC and df dot target double equals to 0 like this also. Am I right? I hope you know. Let me show you that one as well. Df dot what exactly? Target double equals to 0. What result we are going to get? Good. Boolean we are going to get. Nice, sir. But I don't want Boolean type. I need a result actually. Then what we need to do, Df of. Very good. You guys remembered the data of pandas actually. I thought gone means gone actually. See the total what exactly? 50. Total what exactly, sir? 50. Can I get for one? Yes. How many? 50. Same thing like that. Second type also. You tell me. Very good. Why empty, Remember one thing. If condition is not matching, first of all, it never throw error. It is throwing false. If false means no output actually. If false means what exactly? No output. Keep in mind that. Now let me just try to show you that. Previous example. Yeah. Now the first one I have added like this. I would like to say this one is what exactly, sir? 2. This one is 1. This one is, we are just trying to understanding the data set. That's it. We are just trying to understanding about what exactly data set. Now let's move on, please. Check it out. Here, what exactly we are doing? We are calling head method. What method? Head method actually. Simple. You can kindly please walk through. Do I need to execute this? No, sir, please. Target equals to 0. The length we are checking. What we are checking? Length we are checking. Do you think length is a method actually? Yeah, 50. Now the same thing like that, df of target equals to 1 and we are calling head actually. The next one is the length function. We are checking the length also. We are checking what exactly, sir? Length also. The next one, same thing like that, 2. We are calling head actually. Do you think simply I'm scrolling? I hope you know these are all steps. Harish, I still remember 1 month back you asked for the same actually. My best answer is check Kaggle, but still will help with URL. Understand the concept and jump into Kaggle boss. I still remember actually. Harish, did you understand? But let me help you with examples. Sir, if you are interested, hold on. Look at my screen. If you are interested actually, if you are interested, ML, we are having lot of examples. Let me show you. What is this? Go to Lord have mercy on me, and can somebody help me? AI project, something like that. There is a folder. There should be a folder. Real-time projects. Not this one. Kindly please give me 1 minute, please. Real-time projects. Not this one, sir. I still remember. Where is the folder? I will show and I will continue, sir. Otherwise, I know you will scold actually. Let me show you. AI projects, R&D projects. Yeah, exactly. Good. Here is the folder. Seems to be long back I copied actually. R&D projects, AI seed main. Now tell me, first one we are covering what we done, regression, right? Under regression, let us open linear model. What model? Look at this one. As I told you, there are many examples, right? Linear model, click on this one. In simple linear regression, on an average 3 to 4 examples we done, right? Now just try to see here. And if you want, can somebody tell me here what is the number actually? Here what is the number? Any idea? 268. These are all ML related examples, sir. Only regression. Only regression actually. But let me tell you, if you do this one, you can create your own algorithms actually. We have collected these are all examples, right? Simple linear regression. Somewhere you can cross verify. Same thing like that. Go back. Lasso regression. That is still we need to cover actually. Lasso regression. Min max scalar. Go back. Currently we are discussing what exactly random forest, right? Under random forest, would have such a nice examples, right? Next one, go for classification. Classification. Click on this one. Classification. And the classification that too separately. Random forest. These are all examples, right? Chapter wise, would you have an example I can upload? Don't worry. I still remember, let me tell you. Harish, your belongs to interview or internship batch actually, previously. That's what we didn't share. Okay. Anyway, these examples we are sharing for the regular batch actually. Let's continue the discussion. I can remember the name. All right. Let's find. Where are we? What is the topic name? Tell me, sir. What is the topic name? One more time. Random forest. Random forest is an algorithm. Ensure that we have to remember actually. Displaying the length of the target equals to 2 flower. I hope you know. This is the last third type of flower. What is the length actually? 50. The total, what is the length? 150. Good. The first 50 belongs to, yeah. Please observe here. Here, what exactly we are doing, this step is not required, but if you want, you can add. Hello, Daniel. 0 means what is a 0? I don't know. And even 2 means what is a 2? I don't know. Can I give a name actually? You can give a name, sir. You can give a name actually. Let me ask a simple question. Can somebody tell me what is an apply? Method belongs to? One more time, everyone. Method belongs to series actually. How you can say, df dot target means single column. Df dot target means what exactly? Single column. And we are calling apply method. We are calling apply method. If you wanted to add name of the column for the existing data frame, this syntax we need to follow. This syntax. It's a kind of simple lambda. Lambda of, name of the column, iris dot target underscore names of x actually. But we are going to drop this one. I'm repeating again, while training the algorithm, we are going to drop this one. Why we are going to dropping actually? Any idea? Because new categorical data. This is categorical data, but ML algorithm works with what exactly? Yeah. That's what, even if you didn't understand this step actually, feel happy. Not required, this step is. Almost very near, sir. Almost very near. All setos of flowers. Good, keep in mind that. Can I separate all flowers? Can somebody tell me the syntax is called as a? Slicing. This syntax is called as what exactly? Slicing. Let us just try to separate this one. Next one is versicolor, starting from 50 to 100. As usual, the same thing. The last one means what exactly we are doing, from the data frame, I am separating the first 50 flower. From the data frame, I'm separating the second category. From the data frame, we are separating the last category actually. If you're not providing anything as the end actually, it will access till to the last. Okay. Come on, sir. What is the next step actually? What we are doing? Train underscore test underscore split. Come on. This step is called as a splitting data set. Now, first of all, let me prepare X and Y data preparation actually. Let me just try to prepare a data preparation. Step number 3. Step number 3, which is called as a data preparation. Let me just try to call this. This is not we added actually. Yeah, importing the libraries, loading the data set, data preparation, loading the data set. What is the function name? Load underscore iris, not read underscore iris. What is that one? Load underscore iris. Data preparation. What is the function? Yeah, here we are simple using data frame, right? Data frame of drop off. Target is not required. Next one is what is not required? Flower names is not required. When let me just try to print X. Let me just try to print what exactly? X actually. Can I say these are all feature names, boss? Yeah. We are using these features to train the model. We are using what exactly? These features to train the model. Same thing like that. What is the Y actual? Any idea? Yeah, target variable. You guys need to print this one. Let me ask a question. Are you comfortable with the Python first of all? You are comfortable, right? Please, you should be strong. If you are very good in Python, these are all very easy, boss. Very easy. Trust me. Now the next one is that data, splitting the data set. The next one is what exactly? Splitting the data set. Let's do that one also very quickly. Step number 4, splitting the data set. Splitting the data set. Now let me just try to take this. First of all, import the function. Let us just try to import this function. Call the function, sir. Call this function. Get ready. We'll have a small discussion here. Can you tell me what is the function name? Train underscore test underscore split. What is the ratio? How many variables it is returning? 4. First one, X train, X test, Y train, Y test. Yeah. Next one is what exactly? Tell me. After 18 examples, now we are entering into the model creation. Now, what is the model name? Tell me what is this one? I know random forest. Is it class or function? Class actually. Yeah, good. Random forest classifier. Let us just try to import this model creation. Not here. Let us just try to make it here. Yeah. Step number 5, model creation. Please observe here. Good. We are creating an object. What is the object name actually? Model random forest classifier. N underscore estimators equals to 40 means 40 decision trees will come. How many decision trees? 40. 40. If you want gear, you can provide 50, you can provide 60, something like this. But as part of our data set is a very somewhat small scale actually. We are providing what exactly, sir? 40 actually. Keyword augment topic. What topic actually? Keyword augment. Come on, let's move on quickly. Model score, we can check the model score. You need to call a method. Training is not done, right? Model training. Step number 6, model training. I thought we can start today careful cross validation also. It's okay. Model training. Good. Sir, once read everyone. Importing the libraries, loading the data set, data preparation, splitting the data set, model creation, model training. Take these steps. What you need to do, just try to copy here. Here, write a code for this. Write a code for this. Like this you need to do. That's the best practice. Next one. If you do like that, then that is seriously very good step actually. Up to you. In your free time, you can kindly please do this practice. Let's move on. Yeah. If you want, you can check the score also. Score, you are checking the score. X test and Y test we need to provide. Then let us just try to run this example, please. Here, if it is providing the 96 is the score, sir. Very good. Model trained very well actually. 100. What is the score? Means the model is giving 100% accuracy. Give any value, it will do the right prediction. It will do what exactly? Right prediction. I have one question. Talk with me in my document. Why 96? Good. Please, other guys also please understand. Now, today I'm getting 1.0, but whenever I'm preparing this model actually, here how I got 96, sir, the getting score, can I say depending upon what exactly? This function. I mean to say that the data splitting is all, shuffling is done. What is done? Shuffling is done based on the material when I was preparing almost 96 actually. But what is the score now? 100 means don't think like the change is the very drastic actually. Maybe 1 or 2% that is okay, acceptable. But here how much percent actually? 4%. How much percent? Are you getting? Good. 4% is changing. Tell me, sir. We need to fine tune, sir. We need to fine tune. The topic name is called as a hyperparameter tuning technique. Hyperparameter tuning technique actually. Tuning technique. And let me tell you, if it is 100, sorry for saying, we should not believe this one also. Why? Because this is the also called as a overfitting. Also called as what exactly? Overfitting. The topic I can cover here. Overfitting and underfitting. Here I can cover. Good. Sir, you texted me, right? Seems to be. Let me delete this. So the next one is a n underscore estimator equals to 40 parameters. Parameter define the number of trees in the random forest. Number of trees in what exactly? Random forest. Sir, simple model prediction. Now you tell me Can somebody tell me 4.8 means? Good. 3.0, 1.5, 0.3. Good. Why we are giving 4? Big 4 features, and at the same time we trained our model with the 4 features. We trained our model with what exactly? 4 features. Then you have to provide 4 only. You have to provide what exactly? 4 only. Did you try with providing 5 here? Actually you can try. You can try, and you do some R&D actually. Sir, machine learning is the kind of some R&D also. You need to do small R&D. Let's take this step. Prediction. Step number 7, prediction with model. We are getting warning, sir. Then what we need to do, come here, dot values. Sorry. Yeah. 1 means, tell me, sir. Setosa. 1 means what exactly? I'm sorry. Sorry. 0 means Setosa. 0 means what exactly? Setosa, please. Don't scold me. You can try by providing the different values actually. This is what we done. It's called as a random forest actually. It's called as what exactly? Random forest. But let me tell you. IRIS dataset. What dataset actually? IRIS dataset. We solved problem by using what algorithm? Random forest. Then what you can do, let me give an assignment. You can still try with the decision tree also. You can still try with what exactly? And you can still try with one more algorithm. What is that algorithm? Logistic regression. This you need to try. Simple. Trying means what you need to do. The total code is the same. Only this one is the vary. Am I right or not, sir? Only this is the different. Total code is a copy paste actually. Only this one. Instead of random forest classifier, let me use another algorithm. Check the score. Let me use one more algorithm. What is that algorithm? Decision tree. Then you can check the score. Then you will understand a very clear picture actually. Right. I'm very happy to enter into the next topic, sir, which is my favorite topic actually. Let us start another topic immediately. Hmm. So machine learning algorithms. Let us list out what are all algorithms we covered till now. Any idea? The first one is, first of all, did you remember actually? Thank God, sir. First one is a simple linear regression. Next one is simple linear. Next one is multiple linear regression. Next one is polynomial feature. Polynomial feature also called as a regression. Keep in mind that during interview they will ask actually. Hold on. Fourth, lasso regression. Hold on. That I kept hold actually. We'll discuss. Fifth one is a ridge regression. Ridge regression. Sixth one is what exactly? This two we didn't discuss. Logistic regression. What regression? Logistic regression. Do you think this is the regression or classification? Classification. Next one, logistic regression, which is called as a binary logistic regression. What logistic regression? Binary. Seventh one is a multi-class. What is that one, sir? Multi-class classification. This one also we discuss. But let me ask a simple question. What is the algorithm name predefined class here and here predefined class? What is the name of the algorithm? Logistic regression only. Remember, you need to remember that. Now the next one is what exactly? Decision tree. Now the next one is what exactly? Random forest. Random forest actually. Random forest. Now keep in mind that these are all name of the algorithms. These are all what exactly? Name of the algorithms. Good. Now I'm going to start the topic. The topic name is called as a K-fold cross validation. What is the topic name? K-fold cross validation, the very first point, first of all, this is not an algorithm. This is not what exactly? Algorithm actually, algorithm. And what is the purpose of this one? Why we need to learn? Let us start. Maybe only we can close the introduction today actually. We'll see the topic. K-fold cross validation. K-fold cross validation. First of all, tell me the steps actually, sir. Let me tell you. This step is belongs to which one? Let me tell you. Tell me the steps. Importing library. Second one. Next one. Everyone knows, right? Next one. Sorry. Splitting the data set. Next one. Model creation. Next one. Model training. Next one. Come and talk with me. Prediction. K-fold cross validation belongs to this topic, sir. Belongs to this topic. Means what is the step number? What is the step actually? Tell me. Six step is tell me, sir. Model training. When I'm talking about the K-fold cross validation, first of all, this is the topic belongs to sixth step. Belongs to what exactly? Sixth step. Till now, we already trained the algorithm, but is there any effective way? Yes. K-fold cross validation is a seriously very good effective way actually. I'm repeating one more time. Almost we have seen 7 algorithms. Almost we have seen how many algorithms actually? 7 algorithms. Except these two actually. All these algorithms, we trained our model very well. We understand how to train actually. But is there any effective way? What do you mean by effective way? I need a good score. I need a decent score for the model. I need accuracy predictions. Then you can go for K-fold cross validation. What is the topic name, sir? K-fold cross validation. Did you understand first of all? Good. Hold on. Let us start this one. Let me tell you. If you wanted to understand this one, definitely I need to go for my father example actually. Case number one. Case number one. In case number one, what exactly happened, sir? My father wanted to train me, wanted to train his son actually. His son name is a, tell me, sir. Yeah, good. What is the problem statement? To recognize cat and what exactly? Dog actually. Then he has taken a data. He has taken what exactly? Data. Total how many images? 100 images. Then splitting also done. What is done? Splitting also done. And what is the splitting ratio? 70 into 30 ratio. Good. 70 belongs to training. 70 belongs to what exactly? Training. 30 belongs to testing. Good. 30 belongs to what exactly? Testing. Good. Then finally, testing score also we got it. Now here you need to remember this is only one time training. Only how many time training actually? One time training. I'm repeating again. Case number one, exactly till now, I hope you already very well known about this example. My father wanted to train me to recognize cat and dog actually. There are total 100 images. Total what exactly? 100 images. Splitting is done, training is done, testing is done. But remember one thing here, how many times training happen actually? Only one time training. Only one time what exactly? Training actually. Now my father is thinking, can I give the training in effective way? Understand. First of all, understand the scenario. Can I give the training in what exactly? Effective way. Yes, he was thinking like this. Case number two. Case number two, I will tell you. Hold on. Just try to, can I train? Can I train to my son? Can I train my son in effective ways? Effective way. Effective way. Yes, absolutely. Yes, he can. He can actually. As usual, let me take the same scenario. Please understand very clearly. I would like to copy paste. These are all things actually. Understand. First of all, understand, then only you can understand the topic. Father wanted to train his son and to recognize cat and dog actually. Total how many images, sir? Tell me, sir. 100 images. What my father is doing, frankly speaking, my father is a bit intelligent man, bit intelligent actually, not much, let me tell you. Yeah, good. What my father done, total 100, right? What he's done is total 500, he splits into, he divided into 20 into 5. 20 into what exactly? 5. 20 into what exactly? 5 actually. Tell me what is the result? 20 equals to 5. What is the result actually? 100. Done, right? Good. What my father done, he started taking 1 to 20. One fold. This is called as a one fold. This is called as what exactly? Fold number 1. Next one. 21 to, tell me, sir. 40. Next one. Talk with me. 42. Sorry. 41 to, you have to tell me. 61 to 80. Next one is 81 to 100. Very good. Now, can I make it this one at least? Is it looks good? Yeah, yeah, yeah. Now this is somewhat looks good actually. Very good. Now what my father done, first to time, first to time actually. First of all, he divided the total data into a 5 folds, splitting. I mean to say that divide the data into 5 folds actually. Divide the data into what exactly? 5 folds. And he started training. This is something like a training number 1. This is something like what exactly? Training in number 1. First time my father started training 1 to 20 images. What he used, first set he is using for testing purpose. What purpose actually? Testing purpose. Remaining all he is using for training. 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 First to time training is done, sir. What is done actually? Training is done. First to time training is done actually. Team, are you with me? What I'm explaining actually? Let us just have to make it very near so that you will understand very clearly. Good. Then for this one, definitely my father will get a score actually. Once the testing is done, assuming that my father is getting score out of 95. What is the score actually? 95. Can I say first time training is done actually? Then second time what my father done, first time I'm using the first two data set as a testing, right? Let me use the first two data set for training. Now I hope you understand what is it, what is this one? Testing. Very good. What is this one, sir? Testing. Now the next one is what exactly? Training. Next one is training. Next one, training. Then again he got a score 96. Now how many times training is done? 2 times. I mean to say that my father is feeling first time the training is not that much effective. Here I'm not performing very well. Out of 30 images, I'm giving 20, 21, 19, 18 score only. Then my father, what he thought, let me train in a number of ways. Let me train in what exactly? Number of ways. Then my son will get understanding about the data. Sir, first time training, right? Even I'm unable to understand the image when I'm seeing the first time actually. Then my father planned for, let me train my son for 5 times, sir. How many times actually? 5 times. Right, good. This is the first, third, second time actually. You tell me. And first two data set he is using for training. And second data set also he is using for training. Third one he is using for good. You understand, man. You guys understand. Next one is training. Next one is training. This is really good training. Here also you got a score. The score will be 95. Assuming that are 94. That is okay. I hope you understand. Next one is training. Next one is training. Do you think training actually? I will cry. You will understand. Good. Testing. Next one is training. Now the last one is what exactly, sir? Testing. Good. Sir, this kind of training, literally speaking, very good training. Then I was running from my father actually. Why? Because how many times training done, sir? 5 times. Now I'm sure I never ever give any wrong answer actually. Why? Because how many times training is done? Frankly speaking, this is really effective way of training actually. Then what my father done, fourth time the score is a 95. And the last time the score is what exactly? 93. Now, my father, what he will do, he started getting, let me get, let me get average score. What is that one, sir? Average score. What do you mean by average score? Any idea? Yeah, good, sir. 95 plus, tell me, 96 plus, next one, 94 plus, 95 plus, 93 divided by, you guys are very good in maths actually. Very good. Now this is called as a average score. This is called as what exactly? Average score. Assuming that on an average score will be 95. Average score will be what exactly? 95. Now let me tell you. Previously, how many times training done, sir? One time. The score is something like a 99. The score is something like what exactly? Sir, don't trust. I used to tell. One time practice cannot bring what exactly? Awesome results. One time practice cannot bring what exactly? Awesome result. But here, how many times training done actually? Five times, sir. How many times actually? Five times. This five is called as a K. K actually. How many folds actually? Five folds. Five fold. Folding means nothing but, set of the data. Something like a chunk of the data. Chunk of the data actually. I mean to say that here, five times done actually. Daniel, can I make it 10 times actually? Sir, we can do. But we don't have that much luxury time actually. Conclusion of the story, I have divided the data into what exactly? Five folds. Can I divide the data into 10 folds actually? We can do. We can do actually. Are you getting everyone? Let me repeat one more time for your better understanding. You will get a very clear picture. Understand the topic like this, then you will get a very clear picture. Simple, sir. First of all, my father started dividing. Okay, he taken all 100 images. He started, he done the shuffling. What he done actually? Shuffle. The data shuffled actually. First, he started calculating 1, 2, 3, 4, 5 till 10, till 20 actually. He's taking set number 1. Next one, he kept separately. The next one, 21, 40. 21 to what exactly? 40. He kept it separate like this, keep on all these things actually. Then my father started. Morning 9. At what time, sir? Morning 9. He started thinking like this. Let me use first two data set is for what exactly? Testing purpose. He hide this data set. And remaining there are how many data sets? My father having 4 data sets. I mean to say that total 80 images. How many images? He started training, sir. He started what exactly? Training. Okay, let me train, let me train, let me train, let me train. Almost stop. The training went 1 hour actually. Training went what exactly? 1 hour. I thought like after this one, my father will leave actually. After this one, my father what exactly? Leave. I thought the training is done. Now my father is telling, dear son, training is what exactly? Not done, boss. Not done actually. Then again he started the game. What he done, previously, let me tell you. Previously, what is this data set, sir? Testing data set. Tell me, sir. Testing data set. Here, I have replied two wrong answers. I have replied what exactly? Two wrong answers actually. I mean to say that I have given how many wrong answers? Two wrong answers. What my father thinking, okay, previously my son, he done wrong answers here actually. Let me train this data set. So that the wrong answer he will understand very clearly. That's the motto. I mean to say that where you fall, just get a good training actually, then you can raise up actually. Then when my father started taking this one is the training data set, I feel seriously so happy. Why? Because previously I understand where I went wrong actually. First of all, do you think I'm doing overaction actually? You are getting right, sir? Are you getting? What is the topic name? K-fold cross validation. Somebody is telling machine learning actually. Sir, what is the topic name? K-fold cross validation. But understand the motto. First time my father is using testing data set. In the testing data set, assuming that some answers may went wrong. I thought that is a cat actually, but that is a dog. The right answer. I thought that is a dog actually, but the answer is the cat. Then I have given two wrong answers. Then my father is thinking, let me make it this one is a training data set. Then he will understand very clearly. Then what he done, the first two data set in a training number 2 started. Okay, till 9 to 10, first two training is done. Again, that 10, the second training started actually. Now he is using for training data set. Now previously, what he trained, he is using for what data set, sir? Testing data set. Like this, keep on the testing data set is something like this. The testing data set, something like this actually. Conclusion of the story, after 5 times training done, sir, now I'm telling to my father, give me any image. Give me what exactly? Any image actually. Because how many times training is done? 5 times actually. That is not a joke. Conclusion of the story, where there is a more training, with this kind of training actually, model will behave like a more accurate. Model will give the very good predictions actually. First of all, that is the topic. Did you understand or not? Can we start the discussion? Good. Yeah, this is case number 2. So let me tell one more time. Understand this one, then we are entering into the topic actually. Case number 1, case number 2, case number 3, case number 3. Sir, did you notice when I'm explaining about linear regression, when I'm explaining about what exactly linear regression, did you notice model dot fit of x comma y I provided here actually? What I provided, sir? X comma y I provided. I mean to say that no splitting. Can I say that one? We didn't split actually. I made it splitting is an optional. Am I right or not, sir? Good. And scenario number 2, the linear regression. Scenario number 2, the linear regression. Talk with me. Model dot. Now you tell me fit of what I provided here actually. Any idea? Come again. Very good. X train and X1 is a Y train. Means here we applied what exactly? Yeah, applied splitting. Applied what exactly? Splitting. Conclusion of this story. What you need to understand, whenever you are giving a training, without splitting also you can do. What we can do? Without splitting the data also we can do. Means we are using all features and all targets actually. Second one will be with splitting also we can do. What we can do? With splitting. When I say with splitting, talk with me. What is the function name, sir? Train underscore test underscore. Very good. Split actually. Now the third one is a k-fold cross validation, man. Third one is what exactly? K-fold cross validation. I mean to say that, k-fold cross validation training. Cross validation training actually. Keep in mind that there are mainly these three cases you need to remember. These three cases you need to remember. Scenario number 1, no splitting the data. We didn't split the data. At any cost, we didn't. My father directly is taking the images actually. He started, so no splitting the data. We trained actually. Now here, we are getting the score will be 99. And linear regression. Even here is a one-time training, sir. How many time training actually? One-time training. One-time training actually. Here also one-time training. One-time training actually. And here we are getting on an average how much score, sir? The score will be something like a 98. Something like what exactly? 98 actually. Now talk with me. What is the next one? K-fold cross validation. Here, how many times training actually? Tell me. 5 times, sir. How many times? Frankly speaking, this is seriously. First of all, this is not a good practice. This is somewhat okay. This is seriously okay. Very good training actually. Now here, even though the score is really accurate actually, average score, sir, trust average score. Best example. Hello, all example, you executed one time actually. Then you can dance, like you understand. No, no, no. Execute minimum 10 to 20 times. 10 to 20 times. That is nothing but a average practice. What practice? Average practice actually. Good. Keep in mind that. Then fine. Then this topic I will continue. Don't miss tomorrow topic. Without this careful cross validation, there is no real time project. First of all. And one more point, the damn sure interview question from the machine learning, the damn sure interview question. Whenever you are going for interview, directly they will ask, explain about k-fold cross validation. What they will ask actually? K-fold cross validation. Here, the data we are folding actually, we are splitting the data. How many fold actually? 1, 2, 3, 4, 5. Means here the topic name is called as a 5-fold. What is that one, sir? 5-fold, 5-fold, something like this. We can apply 10, we can apply 20, something like that. Let's continue this topic tomorrow. Did you understand? I have given just introduction. Kindly please remember this introduction till tomorrow. I will attack the topic directly tomorrow. All right. Then let me upload the material, sir. One minute, 5:30. Let me upload the running notes. Random forest. Don't go for outside, man. Very hot actually weather. Let me stop recording. Any idea?